A very warm welcome to you all from the Schaffhausen Institute of Technology. Thank you all today for joining us for this very special webinar to learn more about the innovative education model at SIT, and more specifically today to enlighten you about this new master's program in computer science and software engineering. My name is Mark Barton. I'm a former news anchor on Bloomberg Television. I'm very proud to host today's webinar. And the idea of today's webinar is to open your eyes to the ethos behind this unique course, which is to create the next generation of scientific leaders. We have an esteemed group of speakers for you today to underscore why this new course is groundbreaking. Dr. Sergei Beloussov, who is the Acronis Chief Executive Officer and the founder of the Schaffhausen Institute of Technology. Professor Michael Widenius, the CTO, the founder of MariaDB, author of MySQL and MariaDB Server, and Professor Mauro Pezzé, the Director of Master Program at the Schaffhausen Institute of Technology. Just want to take you through today's agenda. We are going to squeeze a lot into the next hour. Believe me, we've got a jam-packed hour for you. You will not want to miss a second. In just a second, I'll be introducing Dr. Sergei Beloussov to talk about the future of computing. Then Professor Michael Widenius will be discussing the value of open source. Then we'll have 7 reasons to join SIT from Professor Mauro Pezzé. And at the end, we'll have a couple of questions from you to us about the MSc program in computer science and software engineering. This is really important. During the webinar, you can ask questions to us at SIT via that Q&A function at the bottom of your screen. Please continue to ask questions via the Q&A function. Our SIT team standing by at the ready to respond to your queries throughout. So please tap your questions, tap the Q&A button throughout today's event. And of course, we will be on hand throughout today's webinar to answer your questions as well. Don't forget, you can apply throughout today's webinar. Go to the website, sit.org/admissions. You'll see it. Apply now, sit.org/admissions. That's the website. That's the admissions page. That's where you're going to find out everything about this brand new, unique course, this new Masters in Science course at SIT. Now, there are 8 differentiators when it comes to SIT in this new Masters. A key one is entrepreneurship. Now, what separates this course, what separates SIT from all the others out there? It teaches you how to build and how to grow your own high-tech business. And our first speaker, of course, is the founder of more than 24 companies around the world. His talk today is about the future of computing. And what it does is it highlights one of the strengths of the SIT model and this new MSc course. You've got access to the people who are shaping the future of science and technology. That's why this new MSc course is so spectacular. It gives me great pleasure to introduce the Chief Executive Officer of Acronis and the founder of the Schaffhausen Institute of Technology, Dr. Sergei Beloussov. Sergei, I'll hand it over to you.
Thank you. Let me share my deck. Every time I show this deck, I try to show it faster. So first of all, computing and software are eating the world. Everything in the world today is digital. And one of the problems which we solve near SIT at Acronis is that all digital workloads, applications, systems, and data are very fragile. They could be very easily copied. They could be very easily destroyed, and so they need protection. And there are these 5 challenges on protecting the digital workloads. First of all, it's becoming more complex. There are 50 billion smart devices today, and there are close to 500 billion in 10 years. They are not based in one place. They're based in around 1 billion locations. So endpoint and edge point computing is becoming more and more prevailing. Second of all, it's cost. If IT was just a fraction of cost for most of companies, it's becoming very important part of the budget. Today, there are 50 zettabytes of data and 500 zettabytes of data we expect in 2030. Just one car, one self-driving car can generate more than 1 petabyte of data per year, 4 terabytes per day. And again, this is around 500 billion devices. So if you pay per device, you pay per gigabyte, then it's a problem. Then, of course, security is a problem more and more so. It's becoming autonomous as well, cyber threats. It's becoming industrialized, organized. And so there are 300,000 viruses which are written every day. And they're written by both amateurs and professional organizations, state agents, organized crime. The very important part of the challenge on protecting digital world is privacy. Digital world by definition, by default is not private. Everything could be copied. And you need to have protection, otherwise all of your activity is in the open, and basically privacy is part of being free. Today we are manipulated with our decisions much more than we were in the past because so much data about us is available for good and bad guys. And most importantly, what we've learned in the past days, IT is now a basic need of humans. You cannot even order food, you cannot order water without IT. You have to have IT to perform the seminar. You have to have IT to execute the economy. With that, it is very clear that there is a need of cyber protection. And there are similarities between biological and digital protection. And they are very clear. It's just like we've learned in the current COVID-19 crisis. In the biological protection, you need prevention, you need vaccination, good hygiene, healthy lifestyle, social distancing, and the very same, it's better to have in the digital world. It's better to have a situation where you don't get sick. You need detection. One of the things we've learned with the current crisis is that it's very important to detect sick people, and that's the very same in the digital world. You need to make sure that you understand when your workload is not working. You need to respond, and for that you need drugs, you need immune system working, you need good healthcare and ICUs, and generally it's very good to do the same for the time when you detect a bad program or detect something bad happening to your computer, being accessed by a wrong person, being accessed by a friend who you don't want to see some data. And this should better happen in real time so you don't get too sick. And when you get too sick, you need recovery. You need to recover, and that's the very same with digital workloads. Amazing thing with digital workloads is with digital workloads, you can actually recover from just a copy of the data. And finally, it's very important to have forensic. Here in Singapore, I'm talking to you from Singapore. I'm Singaporean, and here in Singapore and in Taiwan, for example, one of the ways we reacted to the COVID-19 crisis is that we were able to track every cluster of where this could come from inside the country and basically quarantine the people with high risk of spreading the disease. And the very same is very important for digital workloads. So in fact, at the current time, it is very clear that you need to do prevention, detection, response, and recovery and forensic for biological threats, and it's the same for digital threats. And with that, in Acronis, we introduced the concept of cyber protection, which is a complete solution to protect all data applications and systems, which we call collective name workloads. Protecting it from the standpoint of safety, nothing is lost. Everything we have a copy of. Accessibility, you can access from anywhere at any time. Privacy, you can control who actually looks at your data application and system, and you can give and take away the access. Authenticity, you can make sure that there is no way the data you deal with is messed with and it's original. And of course, security. We believe all of this need to be integrated in a single application, single system, single agent, single policy, single technology, in order to make it easy enough to use, in order to make it cost efficient, secure, control, and reliable. And with that, not only we are really building an application for protecting your data, we believe we are building a first cyber protection platform. So this is very short what we do in Acronis: cyber protection for customers, cyber cloud for partners, cyber platform, which allows to enhance cyber protection, and cyber cloud for developers. We also have our own cyber infrastructure at the moment in dozens of data centers and countries, eventually in hundreds of data centers in every country in the world, and in many partners, our own compute storage and networking, and Acronis cyber services. With that, it's important to note that we are the leader in this field in cyber protection, artificial intelligence powered cyber protection, cyber cloud, and cyber platform. And one of the reasons why I have chosen Schaffhausen for my next project is, despite me being Singaporean, corporate headquarters for Acronis is in Schaffhausen. So Acronis is important part of the equation. SIT is a separate project. Acronis solves one problem. SIT is focused on many other problems. And again, Acronis is a medium-sized company. We're about $300 million in revenue, but we expect to grow more than 10x in less than 5 years. And this is important part of our expertise: cyber protection, cyber engine, artificial intelligence, accessibility, privacy, security, general computer science, software engineering, and education. Cyber platform is a massive piece of software, over 50 million lines of code, serving tens of millions of users at hundreds of thousands of locations, eventually scaling to billions of dollars in revenue. So it's a big platform, and it's a leading platform for cyber protection. Building platform is always very difficult from engineering standpoint. And in addition to that, we have built our business around digital marketing, digital partnerships, digital support, AI-driven sport partnership. We even help sport teams to perform better with artificial intelligence as a part of our CyberFit partnership with sports. But again, Acronis is only solving one problem. Real world has many real problems. And in fact, we need better software and better computers to solve them. This is just an example of the world problems: disease and aging, very much dear to us today, environment and global warming, social justice and poverty, wars and violence, space and universe challenges. I am optimist. I believe every problem is just due to insufficient knowledge. And more often than not, you can solve this problem with a computer. We know that the universe is a computer, and effectively laws of nature is software which runs on that, which enables things on this computer. And so better computers can be used to predict just about everything in the universe. As I present this speech, I changed the picture on the right side. So today, with the current calamity, it's about making vaccines. Almost every modern drug, almost every modern vaccine is first made on the computer, modeled on the computer, even tested on the computer before it actually goes to the real life testing. So what is a computer? Computers are effective to Turing machines. This is sort of one of the first computer predating Turing machines. Old brass brains, which is calculating tight in US cost, was still active in 1965. But all the modern computers are effectively equivalent to Turing machine, which is a very simple device invented by Alan Turing, an amazing person standing in the beginning of almost all compute and almost all artificial intelligence we are today. And modern computers used different architectures: central processing unit, CPU, general processing, geographic processing unit, GPU, or tensor processing unit, TPU. But ultimately, all of this is a digital computer. Turing machine is one-dimensional device. Current CPUs are two-dimensional devices. New CPUs coming out to the market are three-dimensional, so they can get a little faster. There will be no four-dimensional device. There are limits on how much you can accelerate these architectures. And because of that, for specialized cases, there are new architectures in digital computing, still digital. Neuromorphic computing, which is similar to what we can expect in human brain, for example, better for the deep learning. such as this Intel Lohi chip, which is already shipping, or Cerebras chip, which is also supposedly shipping, which is a very, very large silicon chip. Neuromorphic memristor machine, which has element of randomization, which is more similar to neurons in the brain, or photonic computers. So neuromorphic are highly distributed, highly parallel for the deep learning task. Photonic computers are designed for much faster processing of simple tasks. Again, very good for parallel processing, which is very important for deep learning. However, all of this is really digital computers. And if for silicon computers, there is a Moore law, which was coined by Gordon Moore, one of the founders of Intel, that number of transistors and resistors on the chip double every 24 months. For overall computers, which are digital, there are these three limitations. First of all is performance and through output overall. Second of all, the amount of power they need to execute. And third of all, the amount of unique digital processing units, transistors, which you can put in a single cubicle, millimeter, cubicle, nanometer, and so on. And so one of the computational complexity experts also involved with SIT, Scott Aronson, estimates that we will hit hard limits in 25 years. There are fundamental hard limits described on the left, such as Margolis-Levitin limit, such as Bremen limit. And so for digital computing, we will basically hit the maximum amount of computation in a single, in a square space relatively soon, maybe in 25 years, maybe in 50 years, but not much longer. You would think like, yeah, well, that's great. We're going to be accelerating for so long time. But apparently not. There are two basic problems, such as many-body problem, which is required to solve and predict nature, predict the performance of the physical matter, or for example, large integer prime factorization problem, which is just about public key cryptography. Apparently, you can just use large enough public key, and even in 25 years on a conventional computer, at least to this date, we don't know how to solve it. Because of that, there are many new computers which are being prepared. This is particularly the Google record-breaking quantum computer as of October 2019. On this computer, Google came up with a program, very fast description of the program, which is the first program which is showing the supremacy of quantum computer. Effectively, this particular artificial algorithm is indefinitely faster on a quantum computer versus a classical computer, and they built fast enough quantum computer. I don't have time to describe it, but bottom line, there are a number of designs. On the left side, we have quantum computers. There is a cold atoms by our collaborator, Misha Lukin in Harvard, which can scale to significant number of qubits. There is ion traps by IonQ and Honeywell, which is another competing architecture. There are a number of superconducting qubit designs, such as Google, and several already available in the public cloud, like IBM. And on the right side, there are more unique examples of non-quantum computers, which are also not digital. For example, black hole. Perhaps we can leverage CERN for something useful, finally. And you can also expect to make a very, very effective computers based on advanced material. One of such computers is our human body. And you can build a very effective memory and very effective computational devices based on highly parallel quantum chemistry and conventional chemistry, biological processes, and advanced materials. With that, we should remember one of the very simple examples of the advanced material computers, which is a human body and brain. There are 200 billion atoms in a single DNA, which actually computes to create a 40 trillion cell in a human body. Which part of the human body is 100 billion neuron cells in our brain, which are very large cells with 100 trillion connections, synapses, and it consumes just 10 power watts, and it's still to date the most sophisticated computing device, which is not even clear we understand all of the physics which are needed to understand for this particular device. And so it is quite clear that not only we can make better computers, there are also a number of places where already today we need advanced computers to replace traditional silicon computers. For example, robots and sensors. If you think about the computers used in robots today, they are very, very primitive. And so robots are very, very awkward. Here in Singapore, we have a most advanced robot in the world, Boston Robotics, as a dog watching the parks. And you know, it's an advanced robot, nevertheless, it's extremely awkward in comparison to any normal dog. You know, other computers, advanced material simulation, you cannot do it on a modern computer. Data storage is highly strange. The hard disk devices are very strange devices today, and they're not very reliable or very efficient. You know, mix between human body or, you know, other bodies and smart prosthetics. Specifically, if you think about privacy, there is a concept of private internet, of quantum internet, which is effectively the only way to have a quantum private way to communicate over long distance, guaranteed by the laws of nature. But for this, you need a very simple quantum computer, quantum repeater, or quantum switch. And unless you have it, you are limited with the distance. One of the collaborators and board members for SIT, Arthur Eckert, recently written a very good article in Nature magazine, basically proving the fact that in order to be able to be private, you have to assume free will, and you have to assume quantum-like communication. I recommend that you read this. Is a very interesting mathematical / philosophical article, real easy to read. The good thing is that once we build those type of computers with a modern architecture, we do not have to wait long for them to be available for general public. We can create some form of ultimate fantasy mainframe where you combine all of these architectures, GPU, CPU, TPU already today, memory stereophotonic and quantum computers probably this year, and some other very strange computers with human brain power in a single system, which can be used in much better way to actually predict things in the surrounding world and solve the world problems, which there are plenty of problems to solve. And as we know now, both violence and biological problems are standing in front of us. However, before we build those computers, we need to solve these 5 different problems. We need to build new advanced materials. Most of these new computers, quantum computers, advanced materials computers, black holes require new advanced materials which do not exist in nature. We need to, and that's physics, we need to build a lot of new hardware, which is part of it physics, part of it is engineering. We need to build software to design those computers. The computers of the future are incredibly complex. Designing manually is almost impossible. We need to build new system software, and Monty is one of the creators of the software, database software, which is part of infrastructure software enabling our modern digital computing world. MariaDB and MySQL, he will talk more about it later today. And we don't have such software on the new generation computers with new architectures, such as quantum computers, or even memory star-based computers. And of course, we need to build applications, because ultimately applications is what we use. And for that, we decided to create a focused effort, which is a science, technology, and education cluster, very large market in Schaffhausen, Switzerland, focused on computers, physics, and business, making money on the side of the commercial to spend it on the side of science and education. Eventually, we want to bring it up to about 2,500 students and 25 different research directions, and it at all times multidisciplinary, at all times focused on combining science, technology, business, and education. These are specifically the directions of research. Mauro will talk more about it later in his presentation. Cybersecurity, information integrity, artificial intelligence, machine learning, software engineering, and robotics and autonomous machines in computing, quantum technology and advanced materials in physics, digital health, new business management, digital law, digital sports and digital education, and digital arts and design in business sciences. Reality is that only interdisciplinary approach works, even to build such a basic a device, very desired device called autonomous car, you need almost all of those disciplines applied in a single, relatively small engineering group at the same time. So how could we build an amazing university starting from scratch? Apparently, it is quite simple. There is two secrets. One of them, we collaborate with two leading schools, Carnegie Mellon University, which is my favorite, and the National University of Singapore, which is the university of my country. Both of them are highly ranked in computer science. We also built groups of people which we called boards. Most important, the strategic advisory board led by Konstantin Novoselov, who is a Nobel Prize winner in physics. He is here in Singapore. Nicolas Gizan, who is one of the most cited scientists living out of Switzerland. He's in Geneva. Arthur Eckert, he was in Singapore, now in Oxford, also one of the leading quantum computer scientists and quantum physicists. Misha Lukin, building the world-leading quantum computer. Mark Hamlet, who was a provost, head of all academic affairs in the Carnegie Mellon University. Also, of course, a reputable board of directors, a very strong group of executives, a very strong connection with industry, and a broader set of friends of the university. Many of them will be involved with hours and days and weeks of their time in helping us to make this venture successful. I don't have that much more time, and so I want to quickly focus on the program. Mauro will talk about it. This year, 2020, we're only launching a program in computer science and software engineering. This program is maybe 60–70% traditional program in computer science and software engineering, and 30–40% is about business science and physics. Next year, we are also going to launch the program in quantum technology and the program in business sciences. All of those programs are 70% focused on the core, plus 30%, 40% focused on adjacent expertise. So if you think about our program for computer science and software engineering, there is really two major differences. So one of them is we're focused on the problem at hand today. We are not seeing any software which is built by a single person. Almost never this happens. I guess Michael is a happy exception. He built 65% of MySQL, but even MySQL today has many dozens of engineers. We believe the typical project anybody will be involved is 100 people, 10 years, 1,000 man years, 10 to 100 releases. And so that would need 5 to 8 leaders from the list I created on the left side, 15 different roles. So 5 to 8 roles should be present in your project. And we believe that there is no place in the world where you are not taught to build just computer scientist or software engineer, but to be a chief architect, or to be a chief program officer, or to be, for example, a chief idea officer or chief science officer for such a medium-sized software project. And what is the difference? We believe there are these 8 things we want to add to traditional computer science and software engineering program. First of all, we want to add communication and direct involvement with advanced people from our boards. I have went to one of the top schools in the world at my time, and to one of the top schools, or rather #1 school of Soviet Union. Most important thing for me in the school was not the courses, but the people I were able to meet and work with, both professors and other students. Second of all, we are really focused on being able to give enough skills to build a company from 0 to 100 million. And I personally will participate in teaching and guiding entrepreneurs out of those teams, both for internal projects and external projects. Then we will teach specifically on how to play one of those 5 roles: chief architect, chief product officer, chief program officer, chief development officer. We believe extremely important is to focus on change leadership. This is Andy Grove, which is, I think, a great example of a person who started as a scientist and engineer and ended up being as an executive and entrepreneur. And that's what he said about current state. So bad companies are destroyed by crisis, good companies survive them, great companies are improved by them. We believe SIT will be improved by the current crisis. We already see that happen. Then science of people, very important, that really most of the time building a company, building a medium-sized software project, building a new generation quantum computer, building even a social project. It's about working with a team of people. It's about actually interviewing thousands of people over a 10-year period for a job, as a partner, as one of your employees. You also, as a software engineer, computer scientist, need to understand business. And we believe that today business can be reformulated in the words of computer science. And so we can explain business strategy, decision science, leadership, and social organizational behavior. Decision science, I repeat here 2 times, it's a mistake, but programmatic marketing specifically. It is very important for anybody who builds software to understand how it's going to be marketed. And this is actually something which can be very much described in numbers. Quantum informatics is, of course, something which is very useful, one of the things which will happen in the near future. And advanced material science, another thing which we want to touch on in the current course. So that is my last slide. What can you do today? You can, of course, become Acronis customer, partner, employee, engineer, executive. Acronis is about 1.5 thousand people. We're hiring another 1.5 thousand in less than 3 years. You can join SIT as faculty or researcher if you are listening to the speech. Or, of course, you can be a customer or investor. And most importantly, you can and should apply for our master program. And this is 3 examples of people who have done an amazing scientific and at the same time engineering, and some of them also business accomplishments with just getting their master degrees and PhD degrees. Alan Turing, of course, John Bardeen, who got 2 Nobel Prizes, and Larry Page and Sergey Brin, who actually graduated from Stanford master program, but dropped out of their PhD studies to build Google. Thank you very much for listening.
Sergei, thank you very much indeed. So much to chew on there. Those 8 differentiators are fascinating. And I think the one that really stands out for me is the focus on preparing, developing graduates for leadership, specifically within the IT, within the science disciplines. SIT helps you to become a leader, to create a team of leaders, something our next speaker is all too familiar with. Now, one element of this course I know is going to appeal to our next speaker. It's the thesis. Now, what is wonderful about the thesis on this MSc course is it can be written on the student's experience in their own startup business. You get access to the SIT Tech Park and investors, or you have access to the business network partners such as Sergei was saying, Acronis, Citrix, Microsoft, McKinsey and Company, as well as in the SIT leading research laboratories as well. Now, I really want to stipulate this level of engagement with business is extremely rare in highly technical master's degrees from other specialist universities. Now, our next speaker is very, very rare as well. I'll tell you why. He's a developer. He's an entrepreneur. He's an investor. He's an advocate of the open source philosophy. Our next guest is a perfect example of the types of people you will have access to and be influenced by at SIT and this new wonderful Masters in Science course. He perfectly encapsulates the spirit of SIT. And even more excitingly, our next guest will be giving some lectures as part of this MSc program. If that hasn't sold them enough, nothing will. You know who he is. He's Professor Michael Widenius. He's founder, he's CTO of MariaDB, founding member of MySQL, founder and GP of OpenOcean VC firm. There's so much wonderful stats about Monty, but all I need to say is one, MySQL is the #1 database for 25 years and has more running instances than all other SQL databases combined. I think I'll zip up now. Monty, I'll hand it over to you.
Thank you, Mark, for the kind words. So, I'm having prepared today a talk for software developers who want to create better software. and also entrepreneurs. And actually, being a software developer and entrepreneur at the same time is a really, really rare breed. But we do need more of those. And that is what I hope to encourage with this talk. Next slide. So I believe that open source is a better way to do software. Next slide. And here you have the most common reasons for why open source is just better. By the way, all these slides are meant to be used as a reference for future. So I will not go through all parts of the slides. I will hope that you can take this and use them in the future as a reference. And I hope that SIT will also, when they publish a video of these talks, also includes the slides separately to make things easier for you. But I think that the most important things, not from a developer point of view, but for user point of view, is that by using open source, you are in charge of your own future. You don't have to depend on another company who goes out of business and the software disappear or they remove things. You can ensure that this is software that you can continue using basically forever. And that's why MySQL and the successor MariaDB is still going strong after more than 25 years. Next slide. So the reason I started to use open source was that it was good software, it was free, it was easy to use. But I very soon learned that it's also a better way to develop software, because you can find ways to enhance your software in ways that you never expected that you could do before, because you get ideas from the outside. And you get, of course, more developers, more eyeballs. That's basically why Linux is so popular and stable, just because you have so many different people looking at things. But even if open source is a better way to develop software, it's extremely hard to create a profitable company developing open source. And when we started with MySQL in the old days, people basically told me that there's no way you can make money by giving away everything for free, because you will not have enough money to pay developers and so on. Fortunately, with MySQL, we were able to prove them wrong, and I hope that the next slide will also give you the advice how to do the same. Next slide. And this is a great quote from Bruno Lavagay. Why it's so hard to make money on open source. Because if people and companies can use it for free, because your license is too forgiving, there's no way that you can make enough money. And he changed his license from being Apache software, which is very, very free license, to and another one that more restricted, and that was the way that he was able to save his company. Next slide. So when you talk with open source advocates, there is somewhat of a religious aspect of it. Some people believe that open source will save everything and you don't need to take care of money because it will come up by itself. But unfortunately, there is no guarantee that you get enough money working with open source to be able to develop and support your product. And when me and David Axmart went open source with MySQL, we did it very, very carefully and with great thought to be able to assure that we would get enough money to create a sustainable company and be able to work on it full time without having to do things on the side. Next slide. And I think this is probably the most important slide of the whole deck. Why license is important. Because most of the open source companies, at least in the past, they were basically service companies where the source was available for free, and they only provide the support, training, and consulting to help run the project and also enhance it. But that also means that if they earn 1 million and they go to investor, the investor will say that, okay, your company is worth 2 million. But if they would instead do licenses or do have something that will ensure that a part of the users has to pay, either by licensing closed source software or something, then revenue is totally different. And it basically 10x the revenue. So with MySQL, at the time we were sold to Sun for $1 billion, we had a revenue of some 70 million. And 70 million times 10, and we also had some 20 to 50 million users. That gave us a valuation of 1 billion. But if we would only have done services, we would only have been worth around 200 million. So it's a big change, especially when you talk with investors. And that's why licensing is so important. Slide. So why go open source? There's lots of reasons, but if you want to compete with really big vendors, then you and you have less money to do that, you need a different strategy. And open source is a way to get out the product to everyone who needs it, and also get development done at a much lower cost than traditional software, because you have a community to help you. So you basically get free marketing and free help and better bug reports. For example, with MySQL, during the first 5 years, we didn't have any salespeople, we didn't have any marketing, we didn't have any lawyers, and we still was making good money just because we did get things right. Next slide. And this slide is kind of important because it tells you why people or users are going to use your software. And with open source, especially in today's time, it's very important that you don't have a vendor lock-in, because why would you risk your whole business on a vendor that you can't trust completely? If you use a commercial database, how do you know that what is the cost for the next license that you have to renew, or what happens if the vendor drops the project? And even worse is what is there is hidden trapdoors in the product. And that's also, for example, while China is very restrictive for their future software, they want to be sure that there is no trapdoors. And there's also other companies who say the same things about China. If everything would be open source, we wouldn't have this discussion. Next slide. For developers, it's obvious why open source is better. You get the freedom to change things, fix bugs, have other people helping your bugs. Usually you don't have to do this because most successful open source software have a company behind them, so they can help you. But you have the freedom to be able to do things yourself and not depend on others. And you can also learn great things from great software. Next slide. What is important to understand when doing business on open source is that there's a lot of different licenses. In practice, you only have to care about these 5. And if you create a project, don't use any other licenses, because that will just confuse your users. And the public domain on the top is the most free one. Basically, you can do anything with it. And the lower you go down, the more restrictions there are in how you can use the software. But restrictions also gives business opportunities. Next slide. So when looking at things of how to make money on open source, it's not that many different models that exist. The most common one that people refer to is open core. And Then you have dual licensing, what was MySQL was using, and then you have service models. The service model had a problem is that you don't get enough money to do things, subscription, donations, and foundation. But the next slides will go in all of these in great detail. So next slide. So open core is the most common one, and what it means is that a base part of the product is open source. You can use it in any way you want. But then there are modules that you have to pay for. And this is a great business model. Lots of companies are doing that successfully. But if you're looking at it with the eyes on open source user, or if you want to keep the freedoms that open source promises, basically open core removes all of those. In practice, as soon as you're depending on one single module, it is like a closed source product, because you can't fix things, you're depending on one vendor, and so on. It doesn't mean that it's not a good business model, but there are betters. And this has nothing to do with open source, because some things are closed. Next slide. So dual licensing, that's what we use with MySQL. And in some sense, we are using also with some project around MariaDB. So we were, GhostScript was the first project to use dual licensing. MySQL was the second, but we were the most successful in doing that. So the idea is that all code is free, everything is open source, you can use it according to the open source license. But we used a license that had some restrictions, and with MySQL we use GPL. And GPL is great in the sense that if you are working with open source, you can use GPL almost any way you want. But if you have a closed source product, you can't use GPL as part of that, because GPL says that everything that you've attached to this code will also become GPL, in other words, free. And big companies doesn't like that. So what we earned money on was not only support, but giving companies like Adobe the right to use MySQL, but under another license than GPL. So they wouldn't have to make Adobe open source. And a big part of the income that we got from MySQL came from these license deals. And it was because of these license deals, we had a valuation of 10x the revenue instead of just 2x. And GPL works greatly for infrastructure projects, things that people want to embed in their product, like Adobe wanting to embed MySQL into their product. Unfortunately, it doesn't work for all projects. A GPL, which is like GPL, but affects things on the internet. So if you have a service offering on the internet where some parts of it is a GPL, you have to publish all your code as open source to all your users. And that's why a GPL is a way to also earn license revenue from big vendors. Next slide. The problem is that if your product is not an infrastructure product, or things that embed like a music player, none of the previous versions really works for you. And that's why David Axmark and me created the business source license, which is a way for people who believe in open source, create more open source, but also be able to create a company that actually can do revenue. So the idea is quite simple. All source code is available from the start, so all the freedoms that the developer needs is there. But it's not an open source license in the beginning, but it will become one, because the license in every software file tells you that at this date, this code will be totally free as an open source license. And that means that you can depend on this in the future, because even if the vendor goes away, you can still continue to use the software. Maybe you have to pay for the software for 1 or 2 years, but after that you are free and you can still innovate and develop it while you're working on it. So next slide. So the benefit for users of Business Source is that no vendor lock-in, all source code is available, exactly what you would expect from an open source. You have to pay the vendor if you're going to use the latest version, but if the older version is good enough, or you can wait, then you will eventually be free of the payments, except of course if you want to have the support and the latest version. But so this is basically a unique breed between conventional closed source licenses and open source, and will in the long run create more open source software. Next slide. So the recommendations that we tell people that, when they should, if they should decide to use Business Source license, don't make it too long before making it free, because in that case you will don't get the spread of this software that you want. And for those people that you decide that should pay, only target a small piece, because you want to have the spread of open source. You want to have the developers helping you succeed. And if you do like in MySQL, we had a target that only 1 in 1,000 should pay. If you have enough users, that's a really, really good business. Next slide. So here's some links that you can look at later, discussions about open source. Bruce Perens has also written a very positive blog about Business Source, and as a good way for those companies who can't afford to do fully open source in the beginning. Next slide. And of course, there's lots of confusions about why did we do this. The reason we created open source was actually nothing to do with MySQL or MariaDB. I mean, we created Business Source. It was so that the Open Ocean Capital, my investment company, we could more easily invest into great software companies who wanted to be open source but didn't have a business model. By helping them adapt to the Business Source license, they can create a sustainable business and also allow us to do investment in the company without the big risk of losing money. Next slide. There's some projects who are using it. BSL is still new, but Cockroach database recently switched to Business Source. MaxScale at the MariaDB Corporation and Kafka tools are using it. And we hope that lots of new entrepreneurs will see the benefit of Business Source and using it. Next slide. There's also other version that is a little bit like BSL, but basically they say that you can use this software for free in these cases you have to pay. But the big difference with BSL is that we guarantee that, the license guarantees that the software will eventually be open source in a short time frame, while the other licenses doesn't. Next slide. So the Commons Clause license basically looks like this, but we can skip to the next slide. And there are also other kind of BSL licenses, but they all have the problem is that you're still depending on one company for doing that for all future. And that's why I like BSL much more than these licenses. Next slide. So the importance of licenses, without having a way to get a certain amount of people to pay for MySQL, we would never have been able to succeed. We would never have been able to pay developers. Subscriptions are good. You really need those. You want to give customers excellent support, and companies are prepared to pay for it. But unfortunately, if they don't have to pay, a lot of companies will not pay. And that's perfectly okay with open source software, that you have lots of people or companies who are not paying, but you have to have some companies to pay, otherwise you will not succeed. Next slide. So what made MySQL successful? The license was probably one of the most important aspects, but we did also lots of other things that was totally different back then. We were a virtual company from the start, basically hiring developers everywhere, everybody working from home. In Corona times, this is the perfect way to do business, and this is what we're doing with MariaDB. I also wrote 30,000 emails helping people during the first 5 years. And I believe that that was what helped bootstrap MySQL and also enable us to get a very positive user base who helped bootstrap MySQL. And that was 20 minutes and the end of my talk. Thank you.
Monty, that was fantastic. Thank you so much for sharing your thoughts and experience. And this is why this course is so unique. You get access, you get exposure to the thinkers, the business people, the developers, the entrepreneurs, all those people like Monty, who of course will be giving some lectures as part of this new MSc. Just want to reiterate, bottom of the page, there's a Q&A function. Tap that function to ask us questions about this wonderful new MSc course. Please ask questions. Don't be shy. You're a little bit of a shy audience today, I'm noticing. You ask us questions, we'll immediately answer them. We have an SIT group of people standing by ready to answer your questions, and hopefully we'll have time for some Q&A at the end. But please tap that button at the bottom of the screen, that Q&A button, and fire any questions you want. We at SIT will answer those questions. If you want to apply, please apply. If you're intrigued about this wonderful new MSc course, you know where you can find it. Bottom of your screen, it's there, sit.org. Go to the admissions page, sit.org/admissions. That's where you apply to this for this wonderful new course. And by the way, some of you have been asking, how do I get access to today's webinar? How do I get access to today's slides? It's all going to be on the sit.org website. Don't worry if you missed anything, if you arrive late, if there's anything you missed or wanted to look over again, go to the website, you'll have full access to today's webinar. Now, like I said earlier, like Sergei said as well, there are 8 reasons why this course is so spectacular. Now, our next guest, our next speaker, he of course is on the executive board of SIT. Now, it's the reputation, it's the expertise of people on SIT's boards that makes it such a key differentiator. They have a genuine influence on the future success of SIT students. What they do is they connect them with their own networks in the computer science and the technology industries as well. There are just so many exciting elements of this course, such as how SIT can help you build hardware, algorithms, and software for quantum computers. How do they do that? Well, many people on SIT governing boards are working on the bleeding edge of quantum computing to build practical computing devices superior to anything classic. I want to move it on. I want to introduce our next speaker. He is the father, he is the heart, he is the soul of this new MSc program. He is, of course, Professor Mauro Pezzé, Director of the Master's Program in Computer Science and Software Engineering at the Schaffhausen Institute of Technology. Mauro, I'll hand it over to you.
Thank you, Mark. Thank you very much. As Mark says, I'm the architect and the pusher of this master, and I think I don't have to tell you why to actually study computer science and software engineering, because I think Sergei and Monty gave you millions of reasons to study software engineering. Let me actually, since we are running late of time, let me actually answer live some questions while speaking. So I saw questions like, what you need to actually apply to the master. You need a bachelor. Okay, a valid bachelor, that's enough. Why you actually should apply to a master, why a bachelor is not enough, because of computer science, because software engineering, because of the innovation. The world is going much beyond what we need, what we know now, and you need more information. You need more deep insight of not just how to build software, but how software will be in 10 years' time. Do you know anything about the new materials? Do you know anything about quantum computing? Do you know anything about how to build the big software infrastructure with 15 managers and hundreds of people working on the software infrastructure just with a bachelor. Bachelor is fantastic, but it's not enough. So let me actually go ahead with why we should, the reasons to actually study software engineering in this master. I need the next slide, please. Okay. Okay, we have, I drafted 7 main reasons to join this master, you know. First reason, okay, well, I started the master 20 years ago in Milan, it's successful. I started the master 15 years ago in Lugano, it's successful. Why the hell should I start the master at SIT? Because this is the new master. Sergei and Monty gave you some ideas why you need to know technical stuff, why you need to know science, why you need to know engineering, why you need to know business, and none of the masters you find around give you all this mix of really important elements that you need to do to actually study the master. And so the second part is, and that comes to the program, you know, we actually have a program, a unique program that prepares people not just good software engineers, not good software scientists. We prepare key leaders in science and technology. Other element which is extremely important, you had heard Sergei, you heard Monty, you will have access to the top world leaders in science, in technology, in business, in engineering. You know, you will directly talk to Nobel Prize winners to know how to win the next Nobel Prize. Teaching, you know, we are not teaching like classic programs. So, you know, you will find a completely new way of teaching because we are new. We have not this huge ancient legacy of like big rooms, big professors, big courses. No, we are agile. We can actually address you in a way which is completely different from what we've seen so far. And then the other thing which is extremely important, and you see this today, you know, the talks were not like professors, they were entrepreneurs. They were people who actually build new solutions, people who build new companies, people who actually also made millions, billions of dollars, you know, and that's not too bad. And so we need, you know, it's not just a matter of learning, it's a matter of merging together research and business. It's a matter of actually getting the synergy between the two things. And we also have partners. Today, we have a double degree with Carnegie Mellon University. Today, we have a double degree with the National University of Singapore. You can get not just international degree, transcontinental degree. You get a European degree, you get a North American degree or an Asian degree out of 2 of the top schools. You know, we're talking about top 5 schools in the US and in Asia. And we actually want to get to the best students. So we want to actually attract the students with strong and rich scholarship. Now, let me tell you a bit more. You know, what is an exciting program? An exciting program means merging technical skills, merging management skills, merging leadership skills. How do we merge this? Well, we merge them by actually having courses like quality engineering, data science, cyber protection, architectural structure, deep learning, quantum informatics. You know, it's not just like the classic algorithm study. It's not just a classic. Yes, you know that. You have a bachelor. We go beyond that. But it's not only that. We talk about product, we talk about marketing, we talk about design, we talk about transformational change management, which is the way you actually manage large projects. You can be the best architect, the best software engineering in the world, but managing a team of tens of people, you need to know also how to manage people. You need to know how to deal with people. You need to know how to deal with things which are not located in one single element, but spread it around. And leadership. Entrepreneurship, agile leadership, customer-centered mindset. This is what we teach in the master, which is far beyond what we actually have usually in any other classic master. Now, second element, we will meet leaders in research and business. Of course, you meet me. Well, you know, that's not the big news, but you know, I am actually the editor-in-chief of ACM Transactional Software Engineering and Methodology, which is one of the 2 top journals in software engineering. I'm not talking about the journals in my own university. I'm not talking about journals in Switzerland. I'm talking about journals worldwide. I actually wrote a book which about 15 years ago, where there were no course at all on software quality, and now every single university has a course on software quality and software testing. I graduated almost 30 people now, I say 25, but more than that, PhD students. I'm not talking about the hundreds of bachelor and master students, 25 PhD students. Well, you know, what they do? Well, one is actually professor at Georgia Tech, top 5 in the US for computer science. One is professor in Polytechnic of Milan, top 1 in Italy and top 10 in Europe. One is professors in Bicocca, one is professors in Spain. Well, so it's you know, it's the fantastic part of my job, getting people working with me and getting beyond what I can do and what I can do. And but it's not only me, of course. You know, we have René, who actually was, according to Forbes, the 3rd highest top highest paid marketing executive. We talked with Serguei. You actually listened to him, and I don't have to introduce him again. You talked to Barry, who is the worldwide expert in security. We talked to Arthur, who is famous for his work in quantum physics. You talk to Anton, who is a decision scientist. You talk to Candida, who is a security advisor. You talk to Stas, who actually got a prize for his enormous job in security from Bill Gates. You talk to Bruce, you talk to Kostya, who actually got a Nobel Prize. And you know, we challenge you, we want 2 Nobel Prizes from you from after the master. Leading teaching style. What is a teaching style? You know, well, you know, you go to universities and you have now professors who actually give you a lot of material. You get access to web material, you get access to the platform, you get access to e-learning, you get access to the, especially now in the virus era, you know, lectures are online, you know, like exactly this presentation. Now, this is not what we do. We are not just simply teaching online like we were doing 20, 40, 50 years ago. No, we actually build working groups, distributed working groups in the classroom that actually gives you the possibility of being on-site and remote at the same time. You know, we have a team. We have teams of students with professors, with TAs working together. How do they work? We don't care whether they are sitting in Schaffhausen, whether they are sitting in Zurich, whether they are sitting in Singapore, whether they are sitting in Costa Rica, whether they are sitting in Moscow. We care about them sitting virtually in the same room, in the same room, interacting with the people. And this is something that actually is not just something that is simply going online. Is to work in the environment that will be the normal environment for the future jobs. The future jobs is not going to be like you go to the office every morning. Is you actually work in team every day, which is completely different. You know, like now, you know, how many people are in the same location? Probably nobody in this group, but we are over 200 people altogether in this group. Okay, sorry for that. And another thing which is very important, we talked about blending academia and industry. We will actually try to merge the things together. It's not just a matter of like having a blah, blah, blah from industrial people. Yes, we will have people coming and teaching in Lugano, in Schaffhausen. We will have people giving their experience, but we also have you working on projects that are given to us and agreed with leading companies. We work on the project of the future during the master to practice what you learn in the master and learn how it actually can be applicable. We have a top-class academic structure. We have seminars and interviews. We have this fantastic flexible environment which allow you to sit down everywhere you want, whenever you want, to work with us, to join us. So it's going to be really not just online, but it's a personalized digital learning. Okay. Access to teaching, leading research centers. Okay. Well, first of all, you will access the research center of SIT. You will access cybersecurity, AI, machine learning, software engineering, robotics, automation, quantum technology, advanced materials, digital health, business management, digital laws, digital sport. Okay, not everything today. We are building this. You know, we will have half of that already ready by September, and you will actually help us, work with us, building this fantastic infrastructure. And this will give you access to not just us, but all our partners, Carnegie Mellon, Singapore, but every other partner we work with, Cambridge, Siena, many different universities that actually collaborate on different projects with us. As I said, it's not just a matter of like one single experience, but you know, it's more like industrial experience. You know, what does it mean, industrial experience? It means capstone projects. Starting from the beginning, you will not sit in the classroom. You will work in a team on a project to learn what you actually, to apply what you learn in the classroom. Summer internship, you know, we will give everybody the possibility of working in companies during the summer. And yes, you know, let me answer live to the question by Vadim. Yes, we have a fantastic PhD program. You can study the master. I'm so happy that you look ahead. Yes, you can study the master, go with a PhD program, go with an industrial and research and academic and international PhD with us. But let me go back to the experience. You know, you also want to actually, we will actually have thesis. Okay. Each master does not have a master thesis. Oh, but we have research thesis to go on with the PhD to actually learn how it is a research experience. We have industrial thesis, which means working for your thesis in a company. And we have a unique kind of thesis, which is startup thesis. You will be able, as in your thesis, to actually design, plan, and start a company within our park. With you, with the technical leader, with the business angels, with our partners, with our venture capitalists. And, you know, the result of your thesis is a company. It's not just a piece of paper, okay? And then, you know, at this point, you know, I don't tell you that, you know, we think or we give you opportunities for careers that you have never seen in your life. And by the way, I'm a fan of Formula One, but this is not Formula One. This is actually the car, completely autonomous car that is actually the first spin-off of our universities. We build these kind of cars, and we actually compete in the European and world car championships. Now, let me actually give you a couple of more information before I actually give you time for a few, very few questions. We say we are new. Okay, we are new for many things. This is yet another thing. We have a double degree, yes, but not only, we have fast track. So what does it mean, double degree and fast track? The double degree, fast track means being able to actually finish, sorry, I actually have a problem with my keyboard. Okay, finishing in 3 semesters. It's a short master? No, it's an intensive master. You know, second semester, you work extra, you work on Saturday, you work on Sunday, you work on summer, you work on the summer. Third semester, you terminate. You can actually get a complete European style master within 3 semesters. Or you can take advantage of our partnership, get complete full scholarship to actually get that covers both tuition fees and living costs and traveling costs to go to US, to go to Carnegie Mellon, to go to Singapore, to get to the NUS. And at the end of this experience, come back, do your thesis, and you get a master from SAT, a master from Carnegie Mellon, or a master from National University of Singapore. And admission and scholarship, there were a couple of questions. Okay, question number 1 is what you need to actually come to us. You need to want to actually be the leader in the future. This is what we want. We want actually the most talented people. If you have talent and you think you have talent, you want to bet on your experience, on yourself, come to us. Okay, you also need a bachelor. So you need a bachelor in computer science or software engineering of any other discipline, but you need to know something about informatics. So what we actually have, if you have a bachelor in computer science or software engineering, you're admitted. If you have a bachelor in any other discipline, yeah, we'll interview you, not to actually cut you out, but to actually let you know what you need to learn to actually be able to be with us. Submissions, you need to apply within early as possible. I would say it's August the 2nd for non-EU students and September the 1st for Swiss and EU students. No discrimination, just a visa problem. If you're late, contact us. We try to actually see whether we can get a personalized path that actually allows you to be in, even if you're late with the visa. Anything else, fast track, join degrees, after that. You get in and then you can apply and get admitted. And we do have a lot of scholarship available for you to actually, if you really are talented. Let me actually hand over to the question time. So thanks a lot.
Mauro, thanks a lot. Great, great presentation on the meat and bones of this unique new Masters in Science course at SIT. It's Q&A time. Thank you all for sticking around. It's been a wonderful hour full of nuggets. Sergei's here, Monty's here, Mauro is here as well. Gentlemen, please put on your microphones and put on your video cameras as well. By the way, if you still have questions, fire that Q&A function at the bottom of your screen. You can ask us a question. Maybe I can fire one to one of our guest speakers today, or if we don't answer it, we will make sure our people at SIT answer your questions. And don't forget, apply now or whenever you're interested in this wonderful new course. The link's at the bottom, sit.org/admissions. Right. First question to Sergei. In your professional career, how much of you is a leader, a manager, and a technologist?
Unfortunately, in our business, quite often it's very difficult to separate the three capacities. Some teams are lucky and they have this separation. I think I'm more leader and manager, but I'm also very much a technologist. I'm lucky to have a partner like Stanislav Protasov, who is more a technologist, manager, and than a leader. But I think it's that's the whole point, that it's these three things are inseparable.
Thanks, Sergei. Mauro, there's a question about the ability of students, to study on campus or do elements of the course virtually. What are the benefits of being able to study virtually? Do you miss any of the on-campus experience?
Absolutely not. This is actually our bet. Our bet is not to actually offer recorded classes so that you actually miss being sitting with us. You will be sitting with us virtually. So there is this very new, popular and getting popular style of teaching, which is flip learning, which is basically learning by doing. And what we do is we sit down around tables with teams, with professors, working on concrete exercises to see what is missing in our formation and education. And this can be done being physically in campus or being in any other place of the world, or mixed. Come to visit us and be with us physically sometimes and exchange several times. So that's why we can actually accept people, even if we may have some visa problems at the very beginning, because we can get them in the classroom, even if not physically in the campus.
Thanks, Mauro. Perfectly answered. Monty, great question for you. Can you recognize an entrepreneurial gene in a student?
Yes. If to put things bluntly, if you're a hustler, you try to earn money in every single possible way, you probably had the entrepreneur gene in you. And from the other side, from looking at myself, as far as I can remember back, I was always trying to earn money in some way by going, helping people at stores, going to petrol station, cleaning windows, just to earn something. I think that
I think one important difference for Michael, he should consider it. Entrepreneurs also would like Monty, to spend money every possible way, because if they don't spend money in every possible way, then there is no need for them to make money. And so in order for them to be serial entrepreneurs, that's the difference. They just need to both earn money and spend money, right, Monty?
That's why I needed the money, to buy computers.
Okay.
Do you agree, Sergei? Just a final thought. Can you spot that gene in a student? Can you see it?
Well, it's hard to say. People are able to change. They're able to wake up. They're able to mature at different stages. You can spot some negative and positive patterns. You can give some guidance, but ultimately it's a decision which is unfortunately up to a free choice of a person whether he wants to take this responsibility and amount of work which needed to be entrepreneur. So you can, but it doesn't really always. It's not all.
Thanks, Sergei.
It's a boring answer, but that's it.
No, it's fantastic. Thanks, Sergei. I want to thank Dr. Sergei Beloussov, Acronis Chief Executive, the founder of the Schaffhausen Institute of Technology, Monty, Professor Michael Widenius, the CTO founder of MariaDB, author of MySQL, and of course, Professor Mauro Pezzé as well, director of the Master's Program at the Schaffhausen Institute of Technology. Thank you. Big thank you to all those for providing so much value. I'm bursting with information about this wonderful master's course. Just want to tell you a couple of things and we move it on to our final slide. Thank you for sticking with it. It's been a wonderful hour and a quarter. Couple of events to tell you about just before I do. Apply now, sit.org/admissions. Go to the website. That's where you can find out everything you need to know and more about this unique new master's course. If there's any slides you missed, any parts of the speeches that you missed, any videos that you missed, go to the sit.org website. Everything will be put on there, so you don't have to miss anything. It's all on there, the sit.org website. A couple of events I want to tell you about. The SIT Star Contest, June 17th. Stick it in your diary. The aim of the contest is to promote interest in the field of computer science, software engineering, give students an opportunity to demonstrate their knowledge of program and be considered for a fully funded graduate scholarship. There's the link, sit.org/contest/star 2020. And don't miss our next SIT Masters Insights webinar on June the 23rd. Pretty similar to what today is going to be about. It's all about this wonderful new master's program in computer science and software engineering. Join the webinar, learn more about this really innovative education model at the Schaffhausen Institute of Technology. We'll have a guest speaker, Igor Saisoev, founder and CTO of Nginx Inc. So lots to look forward to. June 23rd. 2020. Just to reiterate, if you want to apply, please go to that link, sit.org/admissions. Thank you all for joining us today for this wonderful SIT Masters Insights webinar. We look forward to seeing you again at another time, preferably on June the 14th, on June the 23rd as well, at the next SIT Masters Insights. Thank you to our 3 speakers as well. I'll see you all soon. Take care.
Take care.